Okay, good afternoon everybody. Today I will start one of the important chapters, elimination reaction in organic chemistry, which is very important. That today I will start elimination reaction. Now, elimination reaction means when two groups or atoms are eliminated from a molecule is called elimination reaction. To a very simple way, I can show you. Say XY. If these two atoms are eliminated, the default compound is alkene, or it may be from the same site of XY also. So depending on the nature of the substrate and the base is used, we can write the product. So this is alkene. Now this elimination reaction can be of mainly two types. One is called alpha elimination reaction. Second one is beta elimination reaction. Now, alpha elimination reaction means when two atoms or groups are eliminated from the same carbon atom. Like very popular example, if I give you, that is chloroform. So this is CaCl3. Okay. Now in terms of base, sodium hydroxide, what will happen that this base will abstract this acidic hydrogen from this anion, followed by this Cl will be eliminated to give this kind of species, which is called actually carbene, but this kind of species is formed, plus Cl minus. Now this is called alpha elimination reaction because from the same carbon atom this H and Cl is eliminated. This is called alpha elimination reaction. Now beta elimination reaction, beta means that two groups, actually here the eliminated proton and the living group is 1-2 position. 1-2 position, say living group, say if I say L is the living group and A is the beta hydrogen, this is 1 and 2. Now in presence of base, particularly base, if I use base, so different kind of base will be used. So I will show you that what will happen. This base will abstract this beta hydrogen and the living group will be eliminated in this way to form the alkene. Now this beta elimination reaction can be of two types, various types of elimination reaction. I can show you. One is called E1, that is elimination, E for elimination through unimolecular. So I show you a specific example that it will be understood clearly that, say particularly if I give you this example, to chloropropane. In this reaction leads to the formation of carbocation. Second step, which is the first step, that the hydrogen from the beta position will be abstracted to give this alkene. Now the question comes that why this Cl actually leads to form, or after elimination this Cl carbocation is formed. What is the driving force for this reaction? Now in this reaction actually polar solvent will be used to ionize this alkyl halide to carbocation. Polar solvent. Polar solvent here actually the solvent which is used both as, which actually plays an important role for polarity or polar solvent as well as the weak base. So here methanol or water can be used. So this is a polar solvent as well as weak base also. So this actually polar solvent helps to ionize this alkyl halide into carbocation by dipole-dipole interaction. Attractive dipole-dipole interaction leads to the formation of stable carbocation. Now what will be the rate of reactivity towards this reaction? Rate of reactivity of alkyl halide. Rate of reactivity towards alkyl halide. Now you see that in this reaction, since the carbocation is formed as an intermediate, so rate basically is dependent on the stability of this carbocation. Now based on this fact, we can arrange the alkyl halide towards the E1 reaction, that 3 degree alkyl halide is greater than 2 degree alkyl halide greater than 1 degree alkyl halide towards the rate of reaction towards C1 reaction or elimination through unimolecular reaction. And this is basically based on stability of the carbocation. 3 degree carbocation from 3 degree alkyl halide, 2 degree carbocation from 2 degree alkyl halide, and 1 degree carbocation from 1 degree alkyl halide. Now here the product formation of alkene, two kinds of alkene can be produced from this substrate. So I can show you two kinds of alkene from this E1 reaction. Let us give you one example for this reaction. So this is a simple reaction that I have shown you. Okay. Room temperature, or say around say 40 degrees centigrade. Although here two kinds of reaction will take place, that is S1 reaction and E1 reaction, but at higher temperature the reaction leads to the formation of alkene or leads to the formation of elimination reaction, but at lower temperature substitution reaction will undergo this reaction, substitution reaction. So what will be the product here? The product will be this is plus, that is 2 alkene and 1 alkene. So 1 alkene. This is called Hopland product. This is called Serge product. Serge product. Serge product means alkene stabilized, that is more substituted alkene is the major product, that is called Serge product. Now in this reaction you see that this carbocation is formed from, after elimination, this chloride, and the hydrogen that will be abstracted by this weak base either from this beta position or from this beta position leads to the formation of these two kinds of alkene. And of course here the major product will be here Serge product, because the transition state leads to the formation of this alkene is the major product. Now this is actually elimination reaction, E1 elimination reaction, and here of course the rate can be expressed in this reaction, rate equals to K of concentration of substrate. But here the role of solvent already discussed, that is polar solvent basically will be used just to helps to ionize the alkyl halide into stable carbocation. And the role of base, actually weak base will be used here, because the first step in this reaction leads to the formation of only the carbocation. So second step, which is the first step, where the base will abstract the beta hydrogen. So of course here the role of base either will be strong or weak, does not matter, but actually weak base will be used in this reaction for the second step. So this is all about your elimination reaction of E1 type. Second type that will be very important, that is E2 elimination reaction. E2 elimination reaction particularly if the same substrate will be used here. This is also beta elimination reaction or 1,2 elimination reaction. If I use a base, what will happen? It's a concerted process, that is, we can write here this total this base will abstract either this side or from the alternate beta position. It also abstract the hydrogen in this way and leads to the formation of two alkenes. One, of course, it will be one alkene, that is least substituted alkene, what we call Hoffman product, and another, that is 2-alkene, which we call, that is Serge product. Now the major product basically depends on the stability of the alkene in the transition state. How? We can show you this diagram in transition state. That is, you see that this is the transition state of E2 reaction. So what is the CH3 part? When the hydrogen is abstracted from this base, from this site, this alkene is stabilized by hyperconjugation. Of course, this compared to this one. So this alkene is the major product. That is why you can say this is the Serge product, which is major product. The major product. Now this rate of this reaction can be expressed concentration of substrate as well as concentration of base. It means the rate depends on both the concentration of alkyl halide, that is substrate, as well as the concentration of base also in this reaction. Now the orientation or the formation of two alkene and one alkene depends on the size of base used in this reaction. If I use strong base which is bulky in nature, one alkene can be produced specifically. How? Let us give you same kind of reaction, but if I use here one bulky base, tertiary butoxide base. This base specifically will abstract from the less hindered side proton. This is your less hindered side proton compared to the alternate beta position, because this group will hindered with this methyl group. So from this side, this base will not abstract this beta hydrogen. This will specifically abstract from the less hindered side beta hydrogen. And now the product will be one alkene will be the major product. Here one alkene will be the major product. Here one alkene will be the major product. Okay. This will be the major product. Here Hauptmann product will be the major product based on steric ground, because here the bulky base is used. Now another reaction also where we can also cite, if the leaving group is charged one, like this kind of example. Now E2 reaction, what I have shown you, when the leaving group is any halide, then the product depends on the stability of the alkene in the transition state. But here When the leaving group is charged 1, here the acidity of the beta hydrogen is the governing factor which decides the major product formation of the we decide the formation of major product in this reaction. That is as beta hydrogen acidity of the beta hydrogen. Now between these two beta hydrogen, this one is more acidic. This one is more acidic hydrogen. Of course, this acidity of this hydrogen will be decreased by plus I effect of this methyl group. So this one is more acidic hydrogen. Now when the base will be used, that is the beta hydrogen will be more acidic beta hydrogen will be abstracted first. The product will be 1 alkene, which we call here Hoffman product. This will be the major one. Now in this overall E2 reaction, I have not shown you the stereochemistry of this reaction. Stereochemistry means that the eliminated proton and the leaving group must be anti-periplanar arrangement. This is geometrically more favorable than from the same side. That is, this eliminated, what we can say, stereochemistry. That is, as I have shown you that when the leaving group is neutral one and the base, that is the OH base is used, I have shown you that this ZJ product is formed, that is 2 alkene. Now here actually cis trans isomer is also possible, and we can also say that I have not actually written here, actually we can say here cis and trans isomer can also be possible, and trans isomer is more stable than cis because this alkene can show geometrical isomerism. So here actually cis and trans, mixture of cis and trans isomer is and trans is more stable than the cis one. Now that is what you can say, the reaction is stereospecific. Role of solvent, what kind of solvent will be used in this reaction? Role of substrates, what kind of substrate will be used, or the rate of reactivity of alkyl halide towards E2 reaction, that the branched alkyl halide will lead to or more susceptible towards E2 reaction, because from the branched alkyl halide, that is more substituted alkene will be the major product based on hyperconjugation, that is transistor will be stabilized through hyperconjugation. That is the nature of the alkyl halide will be used in E2 reaction. And the role of solvent is a very important role, plays an important role. What kind of solvent will be used? That is, if I use polar solvent, that polar solvent, what will happen? Polar solvent can solvate this anion. As it solvates this anion, so the abstraction of this base, abstraction of this proton by base will be hindered. So non-polar, specifically non-polar solvent will be used, like acetone or acetone. This kind of solvent will be used in this E2 reaction, non-polar type solvent, because if I use polar solvent, what will happen? That is, the base can somehow will be solvated by polar protic solvent. If I use polar protic solvent, because polar solvent can be two types, polar protic and polar aprotic solvent, but here actually it is a polar but aprotic solvent. And if I use polar protic solvent like water as a solvent, then what will happen, this OH will be solvated by the del minus by polar solvent, and the rate of abstraction by base will be somehow hindered. That is why polar aprotic solvent, which is not capable of forming hydrogen bond, that is called polar aprotic solvent. So that type of solvent will be used. In this way, it will be engulfed or it will be surrounded by polar aprotic solvent. Obviously, the rate of the reaction will be decreases. So this is the role of solvent and role of base and role of substrate has been explained here. And elimination reaction of E2 type can also be shown in cyclic cases. It can also be shown. And another type of reaction. So as I have told you that this elimination reaction can also be cited in cyclic cases, and the essential requirements for this E2 reaction, that the hydrogen, that is beta hydrogen, and this leaving group must be anti-periplanar because they must be in trans orientation. So I can show you. Okay. Now same kind of reaction, you see two substrate I have given here, that I have told you here, this Cl and this H are on the same side because they are on the above the plane, they are same side. So here what will happen, from this side no elimination reaction will take place, because you see with respect to this chlorine and hydrogen, they are on the same side. So the requirement will be the eliminated group and the beta hydrogen must be trans-oriented, must be in trans orientation. And here you see that this H and Cl, this is the below the plane, the above the plane, these are trans orientation, and here actually elimination reaction will take place and leads to the formation of this alkene. That is, so that I have told you, this alkene is formed. And here no cis-trans isomer is possible because this alkene, cycloalkene, is not capable of showing geometrical isomerism. Now this is the case for cyclic compound. And another type of reaction can also be shown here, that is, we can show you. GR form of cyclohexane, and if I treat this with this ethoxide, what will form? The product will be like this, because this H and this Cl, they are antiplanetary arrangement, and it leads to the formation of this alkene. So in this way, many, although this is not actually a stable cyclic alkene, better to represent here the cyclic, this alkene can be represented, because this alkene is more stable with respect to this alkene. Although geometrically we can write it, but we cannot write this one, because this alkene cannot be stable in this chair conformation. Due to another reason, you know, that is due to angle strain, we cannot write it. Now, if I the same cyclic chair form of this cycloalkane, and where the eliminated proton and the leaving group, they are on the cis or the same orientation. H and Cl, they are in the same orientation. So here we cannot write this product. Cannot write it. Now, another type of elimination reaction, what we can say, that is E1Cb. It's a special kind of reaction, E1Cb. E1Cb means elimination through unimolecular and conjugate base. C for conjugate, B for base, conjugate base. Now this type of reaction is a very special type of reaction, not popular type actually. This is for uncommon type reaction. Normally this kind of reaction is very rare, but you can write it's a peculiar type reaction. If this special type of alkyl halide, you see that if I use a base, what will happen? This base will abstract this hydrogen and form this anion, which you call conjugate base. This anion is formed, which you call conjugate base. And here the interesting point is that the bond attached to carbon is quite strong. The leaving group, here the leaving group is this one. This leaving group, that is the fluoride, attached to this carbon atom is quite strong. So this is also a poor leaving group, but still the driving force of this reaction is that this formation of this anion is the driving force of this reaction, and subsequent step is that this is the more stable carbon ion, more stable carbon ion, more stable carbon ion, and after that the product will be like this. Now in this reaction, the rate can also be expressed like E2 type reaction. E2 type reaction, from the kinetic aspect, that rate depends on both the concentration of alkyl halide as well as base. But how can we distinguish E1, Cb and E2? Here the rate can be expressed as alkyl halide, generalized expression. If I write it, alkyl halide base. But how can we distinguish the reaction proceeds through E1Cb or E2 type reaction? Now I can show you one specific example can be cited here. Specific type of example like this from the isotope labeling experiment. From the isotope labeling experiment, say if I treat this alkyl halide, right, the product will be this alkene, that is styrene, and if it is C2 minus, sorry, this should be the ethanol, sodium ethoxylate ethanol, right? Like sodium ethoxylate ethanol, right? The product will be this alkene, and this is quite E2 reaction. The reaction proceeds to E2 reaction. E2 reaction. But if this reaction proceeds to E1CB, and if I use deuterated ethanol instead of ethanol, that this step, that is the carbanion is produced from this substrate as in E1CB type reaction. From the beta position, that is the carbanion will be formed first, and the second step, that is deuterated ethanol, this anion, that is this anion will abstract this deuterium, leads to the formation of deuterated product. But when the reaction, after the reaction, half completion of the reaction, we isolate no deuterated, no, sorry, if the reaction proceeds to the E1CB, so it must proceed to the anion, and after that, that anion will abstract the deuterium, leads to the formation of this deuterated product. But after completion of the reaction, half completion of the reaction, no deuterium is found in the reaction. It means the reaction proceeds through E2 reaction, not E1CB. So this experiment clearly shows that which reaction proceeds through E1CB and which reaction proceeds to E2, that can be distinguished from this isotope labeling experiment, not from the kinetic phenomena, that is from the rate order reaction. Kinetic phenomena cannot be distinguished. And the last kind of elimination reaction, that is pyrolytic elimination reaction, the reaction which proceeds through or under heating condition. The type of reaction will be this type of reaction. Right, first pyrolytic elimination. This kind of ester molecule The reaction proceeds through cyclic intermediate. The transitor will be formed. After that, what alkene will be produced here? This will be under on heating. Okay, better to write. This alkene is formed. So this is pyritic elimination, one example, that is acetate molecule on heating, it produces this alkene. Another class of elimination under this heading or under this pyritic elimination, that is pyritic of xanthate. The same kind of conformation can be represented, but here under heating, you see that this group and this hydrogen is in the syn periplanar arrangement. Syn periplanar. It means from the same side. Periplanar. This is the essential condition to undergo this pyritic elimination reaction, that the eliminated groups must be in the same periplanar arrangement. So similar kind of reaction here you can see, that is this alkene is produced. Class Ame is C double bond SH. From this unstable compound, it forms from MESH plus CS C double S double. So these are all about elimination reaction I have discussed. Thank you.